Yo, welcome in everyone. How's everyone doing today? Hi, I'm back. Sorry about the absence. um yeah, last week I was helping family do stuff, so I wasn't able to stream sadly. And I have been working on the nighttime streams, but I don't think that's happening anytime soon. Okay. Hi Faye. Thank you for redeeming your daily cast. You got a common fable fin. I was worth 8 anchors. Nice. Oh, thank you for the sub, Dino. I really appreciate it. 5 months. Wow. It's a lot of time. I appreciate it. Fuck. Well, the shoutouts are borked. That happens. Let me see. This should work. We'll see if this works. There we go. It works. Go check out Dino. She's really cool. She does a bunch of like games, a lot of chatting, a lot of yapping. It's fun times. Go check her out. Yeah, I need to fix that. List fix auto. So I feel like I have an idea of what's wrong, but it is what it is. Oh, the music's loud. Okay, so today we are going to work on the pathing library. I will explain it as I go for those of you who weren't here or were here and I just explained it poorly. That happens. You know, if you do want to know more about something, feel free to ask. I will try my best to explain it. Cool. It has been 3 weeks since we worked on this. Last week I was gone. Week before that we worked on Side Tangent. So, yeah, 3 weeks. Damn. So basically, without getting too into the weeds, the idea is that a path is just, it's like the title says, it's a fancy line, but I wanted, these fancy lines are defined using specific, like, functions and algorithms that you can combine together, and you get really cool results. And the goal is that the pathing library can handle all of that, and it can handle writing paths. I have a design document somewhere. Design. Then I need to do that, and then I need to bug fix. So this is kind of the plan for the next couple of streams until we finish that. Okay, so the goal for the project is, ignore that. This is the meat of it. You take fancy lines and you want them to be reproducible, but you also want them to be represented by functions because I'm sure like if you take like a low resolution image and you try to make it bigger, it doesn't look great. If we define a path using just like the pixels that it touches, it will look pixelated when we make the path, like if we make the path bigger, if we say, well, yeah, no, instead of being from, I don't know, 0, 0 to 10, 10, maybe it's from 0, 0 to 1,000, 1,000, 1,000. That's for like a grid. And then it would look really pixelated, and that's bad. So if we represent it as functions and specific algorithms, then if we want, no matter how big we want to make the path with some constraints, because of how computers work, you can make the path however big you want. And that lets us say, when we do that, instead of looking pixelated and looking like big, like blocks, it'll still look smooth. Because we recalculate what pixels it's supposed to turn off, I guess. What pixels it's supposed to affect, and how much when we do it based on the size that is given. And we don't have to just kind of blow up the pixels. Hopefully that makes sense. There's a couple of other things. I think the big one that's relevant to what we'll be working on today is this. Because, actually I have, where's main? Tests are over here. Main. Actually, this was important. Does this work? Yes. Does? So size? No. Oh. Where's the print? I have some print statement in here. There. Found it. Okay. Besides that, that was what I was working on. Well, actually, I worked on this a little bit last week. Not that much. Not as much as I would have liked to. So, I have a number. Let's say number is 2 point. Great. Very precise number. This number is important that we keep it accurate. Obviously. So int 64 means we're just going to convert it to an integer. Obviously, we lose all of this decimal place stuff. So we have a few different ways that we can represent this same number. Okay, I'm just going to show this as equals, actually, from decimal, import decimal. True num equals decimal of that. Now, why is this important? Because I believe this goes past the standard floating point precision. So if I say print this versus print true num, so this number, when I print it like this, it gets represented as a float. Float of true num. 64 of true num. Float 16 of true num. And so these are all the different types of float, and we have them because they are different accuracies. So if I print actually no, it's fine. Apparently it's long enough. Wow. I guess I need to add more numbers. Nope, not those, but like this. Okay, see now suddenly it's no longer right. There. So the thing with decimals in... Oh, shit, adds. I guess I'll just continue explaining this. Decimals in computer systems have some issues. It's that we represent them like this. Oh, stop it. If I have this number, I say, well, I could represent it like this, or more accurately, let's say we did like this, so lots of zeros like this. So this is our number. Well, I mean, I think maybe you've learned in school what scientific notation is. I can say, well, this number is the same as this thing times 10 to the power of some negative number. What is that negative number? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, I think. Negative 11. Should be about right. Just want to make sure. This is not how Python works. Python does that. And so there. The way that this is calculated, why this looks wrong, is because of how floating points work. Floating points being decimals. Because instead of showing it as scientific notation, computers don't understand base 10. They understand base 2. So we just apply the same logic. We say, well, what number like this times 2 to the power of x? Because, well, kind of. It'll be some number. This is called the prefix, I think. Whatever. It's called x, and this can be called e, exponent. Basically, your computer, when it sees this, it's like, I don't know what that means. That doesn't mean very much to me. So it converts it to scientific notation, because then you can store very big and very small numbers very accurately. So for example, if I just keep making this more zeros, even though this is just a normal floating point, it's almost 100% accurate. Or it is actually perfectly accurate. Even though this number is huge, because it represents it as a scientific notation, but in binary. So that's cool. But now what if I made this number not nice? So the thing with this system is that it likes really small numbers and really big numbers. But if I did something like 3 point this, it would fail. It wouldn't know how to handle, or it does, it knows what it's doing, but now it has to say, well, I mean, what is this number? And then we give it an exponent that's in base 2, and there's only so much room. Floats in Python and many languages, you'll see this called a double, which is a float 64. It means that We said, this number has 64 bits to figure out what the fuck it's doing. And that's it. In a lot of other languages, you'll see this 32-bit floating point called a float. So this is called single precision, and it's good for basically everything. You really never need anything that's this big. Numbers like this will handle almost anything you need, except for when they don't. So then, when you really need that more precision, you go to double precision, which is called that way because it's double. Float 16, I have no idea where float 16 is used, but it's a standard size for a floating point number. So although it isn't like, you would say, well, I mean, it took this number and called it this. Well, when we go back to this. Oh shit, it's not at all. Well, I mean, it's kind of accurate. It's almost there. Alright, so it works enough that if you really just need like a couple of digits, a float 16 is fine. You will find nobody using a float 16 though. I don't know of a single use for this. Generally, you will use float 32 because it's small enough that it doesn't cost a lot to work with. The thing with computers, right, is that the more data you're working with, the more memory you have to use, the more of your CPU that you have to use to just compute one number. So a lot of the times you'll see float 32, and you'll see float 64 a lot, actually. People use it a lot. Mostly in, like, hobbyist kind of projects, or projects where you really need that precision. I can almost guarantee you that any real program you use uses single precision. Because it's less, and less is always good. This, I don't know if you can see it, you might be able to. This program already takes up like a gigabyte of memory just kind of sitting here. It's idling, it's not doing anything. And it takes up a gigabyte of memory. Which is due to how it works. So, any reductions in that is always good, and a lot of these will have a lot of floats and or a lot of like decimals that you want to represent single precision. That is that. But as I was explaining here, I want to make it so that the paths are cohesive, so that if you provide multiple different precisions, then it will normalize them to one standard one, so that no matter what you... so that the math is actually nice, because NumPy, which is a library that I'm using, doesn't always like it when you mix precisions. It's usually pretty lenient, but not always. And two, so that you know what you're getting out. So if you asked for precision in int, that is translated to int64 for NumPy outputs. And if you ask for float, that's a float 64 NumPy outputs. And it will translate everything into those units, so that whenever you ask for a result, you know definitively the exact thing that you're getting. I'm also doing this because I plan to move this to another language or eventually move some of it at least to another language that's statically typed. What that means is that instead of, me saying, yeah, like, num is 2 I can say num is actually never mind. It's hello. Actually, I changed my mind again. It's actually 4.729 or something. I can do this. Statically typed languages don't like this. They need to know everything up front. And so if I eventually want to transfer it to that, I need to have that framework. I want to have that framework set up already so that I don't have to go in and overhaul everything when I eventually go do that. So that is a, not at all short, but that is a recap of what I guess we'll be working on, what we were kind of working on last time too. Last time we made this, the safe deep cast, and I think safe shallow cast. I think, did I not? Oh shit, I don't think I... Yeah. Are you sure? Because I'm 100% sure I changed this. Give me a sec. So I was working on this on my laptop, and I don't think that I actually pushed any of my changes to the... It's called a repository, and it's kind of the system that I am using to keep track of my projects and make sure that when I change stuff, it happens over all the computers, so that when I do change something on my laptop, like I did, I can push it to the cloud and then I can pull it down on my desktop, which is cool, but I actually need to push it to the cloud first. Work on, what's it called? What do I call it? Made safe shallow cast. There. Command and push. We are pushing to template, yes. This one should be fine. There we go. Now, it should let me update the project from the cloud soon. It works really fast, so it should go look at that, and then there we go. So, yeah, because this is what I worked on last time, whereas utils is over here. And I updated some of this so that the specific system that I'm using is it's called a static type checker. And I need to make one more of these. Safe cast. And kind of the issue with that is when you have a function like this, which types it up here. So I have this path nested scalar. This is the type that it's expecting. But that also means that the type it's expecting to give back when, or the type it's expecting to return when I call the function. The issue is that if I want an end array, so this is the system numpy, and this is kind of the way you represent data as big blocks of numbers. And if I want to get an ND array as the output, the type checker will complain because, well, it could be any of these. And I'm sure there is a better way to do it, but I don't care enough. What is this? MTT ND array. Oh, not you, utils. Here. Com type of scalar. Scalar. I don't think you like this. Yeah. And I have start T is this. How do I have it defined? Base path. Oh, I just called them ND arrays. Okay. Yeah. Yeah, that's fine. ND array. Never mind. Nerd type is a how did I handle ND arrays? Right now. Yes. There we go. Are you happy with this? You should be. Okay. I think. So should be the same logic as everything else. Type pathway npt rate. Yeah. So I'll just use this, and we'll use that here too, so we can be a little bit more precise with specifically what's going in and specifically what's coming out. Okay, now the thing is broken, should we be fine? Cool. That should hopefully mean that now everything can just work, and I just have to go in and change it. 13 NT already changed to the precision. Oh. Yeah, this should be fun. Okay, so in the base path we get the precision. Oh wait, no, this is base path. So in the path So it's called an abstract class. Basically, it doesn't do shit, but it is there so that when I make another path, for example, base path, which is also an abstract class, but it does some extra stuff, it knows that yes, you're a part, that you are a kind of path. Which is good for, you know, making sure that when you get some object, that you make sure that it's a path before you do stuff with it, or that you know what methods to expect. Because I know that any path is going to have a get range, because I said, well, if you're a path, you need to have a get range. Unless you're like this, and it does have a get range. But if you're an abstract class, then you don't. Because, well, you aren't, no one's supposed to make abstract classes. Like, you're never supposed to have a path. You're gonna have something like this. You might have a linear path, or the other one that I have right now is B-spline. And then I need to fix it. And simple, that's fine. Estimate sample size does this. This is fine. Equals none equals none. Rotate. If samples is none, else min samples. Actually, never mind. Just remove all of this, because I'll just have a set min samples thing. Min samples is greater than 2, and no less than 2. A cellular value error. At least 2. Wait, no. We'll just expand this. Plus. This one can close, that one can close. And this one closes, and yep, so what I'm doing right now is I'm just checking and making sure that this logic is fine, because obviously min samples, I'm just basically smarter about this. Min samples tells the program how many samples it needs to actually pull from the path estimated to get an accurate result for the it's called feature size. Basically, when you draw lines between all of the points, because you can't sample like every tiny point every time, you say, well, how much do I have to sample so that I can get a pretty decent look at what this is supposed to be? And that is done using min samples, which the user can either provide themselves, or they can provide hints that kind of tell the program how it's supposed to estimate the min samples, which it does by just grabbing all of the points. Let's say if it says, well, min samples must be 2, then we'll look at 2 points and say, okay, well, if we look in the middle, moved around by a little bit, it's not exactly in the middle, and then we measure how far off the middle is from these 2 points, then we get a deviation, and the missile knows where it is because it knows where it isn't. We can see how much our prediction of where the middle should be is off from where the middle actually is, and then we can give that configuration an error value, and if that error value is below a tolerance, basically how accurate do we want to be? If we are accurate enough for the purposes of the user, then we say, well, that's the number of samples you need minimum to estimate the curve. It's not perfect, but either that or the user provides it, and if the user doesn't provide it, there should be some way for it to still guess. So what do? You have your precision type. Okay, so base path is very simple. Path mass? Yeah, I don't... How do I want to... Yeah, no, they're just... I mean, I guess we can add precision? Yeah, I think that's the best solution. We default to the given path precision. Otherwise, if the user does provide a separate precision, we will cast everything when we actually do. Path of no turn. I assume if I use safety cast of path R and then self.precision, it would complain. Yeah, that's what I thought. Okay, this is so unbelievably useless. I mean, I'll keep it because I have a bunch of logic in there that I do want to keep, but yeah, it's not useful. Where do I even use this? Let me look at types. Okay. Start point. Wait, what? Oh. I think. Does that really make sense? Because then we can. I guess. Precision. I mean, I guess it makes sense there, but it doesn't really make sense to have it in here. Because the only reason this makes sense is that I am then just going to convert it to an array anyways. So it's not actually that bad. Fine, so you do have valid uses, you are dumb. F safe call cast T collection. Our collection of value. What do you mean collection? C type, I think. Okay, and then so we have C type path scalar. But why though? Okay, well, I guess you are a thing that exists, and you can have the type of Hi Immortal, how's it going? Okay, so not everything is broken. That's fine. Wait, no. Oh, uh. Thank you for redeeming your daily free cast. You caught a common frost flounder. It was worth 8 anchors, but you up to 8 total. Congrats on your first cast. Oh shit, thank you for the follow. Hister? Hopefully I'm saying that right. Feel free to correct me. List topple set. Do you really need anything else than that? No? What? It's fucking generic. I don't know a good way to do that without... I guess, let's see, R type of C type. I don't think you like that, no? No. You really dislike that. What does Google say? Cache placement. Type var as generic. Oh wait, shit, I'm an idiot. You would do this of C type. Oh wait, no, of, I guess, some other type? Path scalar. No? Let's see. We have C type. We know where that's going to come from. That's the conversion type. So this is C type. Some R type. Okay, so you can't do that. But what if I did? I don't know. Wow, that's a lot of type. It's a different path scalar. Now are you happy? No. List of the type. List of path scalar, I think. Does this help? No? Cannot be combined with tuple unpacking. What does that mean? Path scalar. What if I did E type in here? Nope. Okay. Okay, how do you make type var inline in methods? What do you got? Do I just... okay. The reason that we do all of this complicated nonsense, sorry I haven't been explaining it that much, is, again, for these static type checkers, which, if I'm using my code, it'll tell me, hey, dumbass, that's wrong. Because, let's say I put in the wrong type somewhere. That's gonna, okay, is this better? The type. What if this was E type? Do you not like about this? No? And basically what I'm trying to figure out is that the idea is that value, this thing, what I'm going to convert is either like a list or a tuple or a set. And I want to just get this list or tuple, that part, because I'm going to take in that of something. So it'll be like tuple of path scalar. Do we do it like this then? Do you like it better like this? No, you don't. You hate it. Yeah, I think. No? Maybe? And it'll be a tuple of some type from path scalar. Path scalar is basically just a list of things that we've said, yeah, that's cool. We can accept that. We can work with that. I guess if I'm going to be using them different anyways, I might as well, right? Just put them separately. That's annoying. We have C type, which is a path scalar. Oh wait, there's a reason we didn't do this here. We could do that here. Type C-type, and then say that we're going to return C-type, and I know you have an issue with it where? Here? Is it not a path scaler? What are you on about? It's an int, it's right there. Oh wait, no. That's why. Wait, no, never mind. This is the right way. Because it'll be the, essentially, contype should be equal to C-type. Except contype is the actual type. C-type reflects that. And so then, if contype is an int, then how? Okay, well, that's fine. I think someone can figure it out. This is unfortunate, but I will just call this is a type. This is a path scalar. This is a list of path scalar. Same thing for this copy path scalar, and then set basically any collection of path scalar. So if I do ... then you stop complaining, so that's fine. Okay. I should probably learn how that type. It's called type vars. I think you might have seen it when I pulled up Google. Basically, it just means that you're storing types themselves as variables, so that you can tell a static type checker. You can give it more information so that it can help you better. But I think some of it you just have to do yourself. A static type checker is not able to do that. What does map get you? What is the ABC for collections? Python collections. See method signature, or I guess see signature. Okay, so container just has a contain. A set contains what? Set inherits from collection. Okay, so that's fine. Oh, it's a okay mapping. No, I need a single. I guess I don't know actually. I just need to have a len size deliverable in container. Oh, sequence. Reversible collection is a set is not a sequence, right? Yes, because you don't have a. Well, no, you do have contains. Oh, but they don't inherit. Fine. This is annoying because I don't want to. I can specify. I could just say, yeah, this is a list or it's a tuple, and that's it. But that wouldn't let people do maybe some of the things that they would want to. For example, like a custom type wouldn't work with that system, even if it is a valid collection that I could, access and use. It just wouldn't work with it because I've only defined a couple of types. And it's not a huge deal. Yeah, it really isn't. I just don't want to. I want to make it as. I guess that's probably part of the issue. I want to make it as general as possible. That is. It's pretty. I don't want to say famous, but it's a pretty. I guess infamous fallacy in computer science is that you need to make it as generic as possible to fit every need, which is not really true. You take that this, though, I can do. The question is, can you? Because either it's set item, which is dumb. You never want to do that. Do all collect and copy. Copy. How does the copy library work? Okay. Copy.replace is not as general. Yeah. Any collection. What does this actually look like? It is a... Oh, abstract methods, yeah. Yeah, you don't require anything. Okay, well, it is what it is. Instead of collection, it'll be... Okay, we have ads in 1 minute. Collection equals... The path scalar. No. Collection. Height type. List of height type. Set tuple of I type. Set. What else are there? It's the big ones, right? List tuple set. Python data types. Collection data types. What? Normal Python bit order. It doesn't, right? It probably doesn't. Oh. Okay, so that's why we have order dict, but it's, I assume, obsolete as of now. What? Okay. That's not what I'm really interested to say. Yeah, oh, that's all the important ones. And this just guarantees that every type the type that's specified here is supported. Oh, you wanted before probably, huh? Path collection. Yeah. Path collection. Path collection. if is instance value list. This. Is instance item path array. Yeah, you don't like this, right? You don't like that it's a type alias? Okay. Types. Path array types equals. It is just a float. In the array, I think. No. Oh, it has to be in the array like this. np.nd array. Path collection types equals list tuple tuple sets. Scalar types, path array types. Our set operations or append operations more expensive? Set? No, it doesn't matter. This is not a what? Dear cast. We should also call this an np.floating np.integer. Oh wait, no. Is instance item.d type, I think, like this. No? No. I mean, it has to be like a valid. Expected end array. What? Expected type. End array. Any d-type integer and a floating any got. Path scalar, not path scalar. Path scalar types. Ret dot append safe shallow cast value type. Oh wait, no, item. Will this solve the problem? It still wouldn't like it, right? Because it's still a list? But because it's not specific enough, right? Okay, yeah. No, this is dumb. That is not dumb. So we keep utils. This doesn't exist anymore. We don't really need that. So we're just gonna have to do a separate one. Well, list. Not really. Okay. But it's fine. L if okay. Oh, I guess because it does know, but it's also kind of stupid, so it doesn't. I don't know. Red. This save. This cast. Why? Yeah, I just told you everything I'm gonna do to the list. Why would it not work? Okay. Expected time. Oh, I guess if I put np.nd array, that one's gonna complain, and then you're gonna complain. But now you will be happy. So what was wrong when I did? Because what is this? This is not just like a link back to np.nd array. Why is this? Okay, so it is. Okay. So don't have this. Oh, I guess because that one happens in the on the fly, so it probably doesn't see that and think about it because it's dumb. Same thing. Or why would I copy the definition? So this would be safe tuple. And then this is just tweak tuple it at the end. What? if we just returned list of map, how does map start? Func, and then you need the function, and then you need the iterable. Wait, no, it returns an iterable. And item is right now. Empty dot array it's this if it's that case, or it's this else this. I think that should be right, but and then I need to do value. Wait, what? Oh, line too long. Okay. That is fair. This is very long. That should be right. Should be better. And then okay, so this is right. You're okay with this then, right? Same what? It's the same logic, but you don't like it now. It's the same thing. What if I said this had to be like a set, and I said, yeah, make it a set. And then you're happy. So what specifically does tuples not like? Okay. What does the map return then? In this case, oh. Oh, because tuples are defined size. How do you specify a tuple of undeterminate length? A tuple of length and type. Okay. No, but I get why they do that. Because otherwise then you might have... because you can specify that this tuple is only allowed to contain this many elements, and that's it. Which is useful. So it makes sense, but it's also just really annoying when it happens and you're like, but why? Why do you not like this? Kids, men and their crazy profanities. So this is the okay. Safe cast, I guess. Value path scalar or path array like that. Path scalar or path array. Type cast R. Turn this, and then we just put a value there, and should work just like that. And we also don't need that. Yes. Font type, and then we just have value there. Yeah, okay, so that's fine. This is all, so now simpler because I just say this is a list. And then I just copy this and do it one more time. And I say, yeah, but this is 4 sets. How many times is someone actually going to use a set with this? I don't know. Probably not that much. But they can now. Like this. There. Save. Double cast. Couple, no, I think this one's typing. I guess can you? This is a big question. Var arg. var this from here? No. Or is var just something you use? Sorry, just give me a second to check something. Yeah, that. Okay. Should be fine. There we go. Where do you import var from? Oh, this is Python too, I think. Is this even Python? This is not Python. What language is this? It's under general use. That's not helpful. What language is this? Oh. Oh. Oh, that makes sense. Why I have type for? Type for type. What's this? What does this do? Can you? Yeah, but that's not the way you do variable types now. I guess this is similar? Huh. type of our tuple is from typing, I think. I don't know if I even used path. Okay. If tuple had a zip path, so path right. If type var hmm def type tuple length. I'm taking the world you see. They calling me, baby calling me royalty. Just to give me loyalty, 'cause I'm taking the world you see. Calling me, baby calling me royalty. Couples back. What if we did like this? Okay, yeah, I think so. Length, my tuple, tuple of, and float, tuple length. I need to turn that off. I don't think you heard that. Maybe you did. Let's do give me loyalty. Full length. Yeah, I think so. That wasn't gonna go anywhere. What do you have to say? I'm gonna move that over here. That that wasn't. Again, I think union is just. Yeah, it's just use the other thing. Just one. Okay. Well, let me. Um, equals type var topple. Yeah. Just. No. Oh, instead of this one up here, what's this do? Fine. And I assume I can just put this again on the other side. It's the same though. Like it's by definition the same length. I mean this might be one of those situations where I just put ignore return type and call it a day. And now what is this? Path scalar path. That's right. What? No. Okay. Well. What was it? It was which thing? This? Yeah, obviously now you say, well, it works now. Yay. No, it doesn't. So either we put this here. Let me just call it a day. And then we don't use this, and we tell this one to shut up about it, I think. This. I mean, I guess an easy way to do it is just this, right? Zero 2 2. Well, yeah, that's what this is for. Is this not allowed to work? Just... yes. No. Just ignore it. Turn it off. Path scale. Alright, let's do the same thing here. Okay, so do you get it if I just remove this? I mean, I think we can leave it there, but instead of this, we just say that equals this for I. Path equals say shallow cast, or what is range supposed to be? Range is supposed to be any path scalar. Yeah. So you path scalar. Path scalar. Say shallow cast path r of 0. That bar is an or. Are you? See, sometimes the code just works, and then sometimes you forget why you even chose this field of study. Why? Yes. Uh-huh. Where? Oh, no. That's fine. I'm an idiot. Self.source, I get range. That's where. Okay, now that is issues with that, that's fine. Okay, now what issues do you have? You have issues with that. I'm just gonna remove. Marker is a thing. You also remove it from there. This, I do I wanna leave this open? No, it's fine. And we have this. Yep, safety cast doesn't exist anymore. That is not being used. Yo, Workus 6. How's it going? Welcome to the ship. Oh. I have anything good ideas. I remember, what was I? Yeah, no, it was just kind of like verbose, just all of the parameters. And we don't even use that. Great. ABC is now fully brought up to speed. I don't know why I had that already X'd out, because that was not done. Next, space paths. Okay, well, let's look over. Get range is the only thing that returns shit, so that's fine. And then it makes sure we shallow cast to the one that we want. You actually have precision, but what's... Yeah, min samples are just an integer. This isn't gonna be that way. If you want to ask about it, what? If you want to ask about it, sure. I can try. Space paths. So do this. The only thing that we care about is min samples can be in whatever format we want. That's just an integer. That's the settings, and then tolerance is our, well, tolerance. Take me to a world of sleep, no more heartbreaks, tears, painkillers. Me somewhere unfamiliar, bring me back to where we started out. Wasting time, up and far. Myself, it's fine to be alone. Mm. Let me import numpy dot types. Typing is in PT. R equals np dot print this instance. Does this work? This does not. Okay, so yeah, so having this on here is I still am, I think. And this is just Oh yeah, let me. Oh, let me see that. But I do want to put. Yeah, I don't know why I did it this way. So I'm going mainstream. Mainstream. So I'm going mainstream. Oh, mainstream. That should be fine, right? Yeah. I'm going mainstream. Oh wait, no, it just expands them anyways. Yeah, I don't, you know. We got an ad in 2 minutes. Okay, so where's the first error? Start self-dot precision, self-dot precision. Like mainstream. Mainstream. It does. I don't think NumPy gives you a warning if you do something stupid, right? This step equals 0.3. Okay, and then if we do nt dot array r deep type equals int. Does it complain or does it just do it? It just does it. Okay, so that is not what we want. We need you to utils safe array cast safe shallow cast. I should just name that safe scalar cast so that it matches everything else. Utils safe scalar cast. Hooray. Hooray. Start feed NP, and we use them as references. How does it just take its best guess? It might. And then you can do say array cast. Wait, no, it start p self dot precision, right? That's the way we did it in ABC. Yep. And it's the same thing here, except it's init and p. I mean, they need to have the same shape anyways, so. And how do you handle that? You just leave it there, okay. No. I guess that's where documentation might go. Yeah. Okay. Well, we're not doing that right now. Wait. Yeah, no, it's just a tuple. Of its int dot dot dot. Right? Yeah, that's what a shape looks like. Yeah. And override. Yeah, and this should be a path array. A bunch more things that I forgot I need to change. Path array, which needs to get imported. This returns a path array. Right? Think so? Yeah. At is not a path scalar, it's a path array. Path array is a path scalar, and you're going to return a path array. At dx is also a path array. This is a protocol. Path array. Path array. Nope. Features. It looks more like that. Yeah, that's fine. Does it not? I'm like if I find np dot int64 of like 2. Oh yeah, integer doesn't, but all of the subtypes do. Features at dx. This is the same as this. Hold tight, hold tight, hold tight, hold tight, hold tight. That's not right. Man. Zeros, 3. Start, and this np dot 133. Wow, that's impressive. It's literally 2 seconds. Huh. Yay. Voltage, voltage, give me close, voltage, voltage, voltage. Start T and T. What was it? It was start times. That's not right. Start times start minus I plus and oh wait, no, this is I. And T, and this is in np dot np dot in space start T and T. No, like 9. Send times T. I think it's the other way. That. Oh yeah, that's not right. It's. That I know this is just divided by entity minus 13. That's what I thought. I'm just dumb. Start p times end t minus t t minus self dot start t self dot end t minus self dot start t, and that should be right. Okay, so what methods have we fixed? We fixed init, we fixed return shape, at start, at end, at dx is always going to be the same. Points. Wait, what? Oh yeah, no, because we don't, because there's no get dx. There is no. What does render return path array? Fuck, where does enumeration go? Didn't enumerate. List enumerate range 2, 4, like 5. There we go. Index first, element afterwards. I, T. I know what you want. You want me to add the override annotation? Fine. I want to move this up, and then I want to make it slightly more efficient in the way that it works. Because this is, I mean, like, this isn't bad. But it's kind of bad. Would you count? I might be dumb. If we do this, then the first dimension is samples long, right? So mg dot zeros shape samples get Get return shape for this. Get return shape is a that. In space. Right, like if I have, for example, if I have r s star equals np dot zeros 3 and equals np dot full 3, and then fill value is like 10, and I mean, yeah, and so points that append. I mean, 1, we can say points of I equals this, because self.at returns. Point of 0 equals self.at 0 at start points at -1 self.at end, and points in the middle between 0 and -1 equals np.linspace. No, like this much, and then samples -2. Samples. Yeah, it's less than 2. Why did we have... sometimes I don't know what I do. Yeah, it's just the other one. It's the same thing. Why? Be 2. Must be at least 2. Right. Greater than 2. One. And I mean, we just return points. precision. What's it doing here? Yeah. And empty dot space start end and whatever, like 10 samples that we want, like 11 samples that we want. It's a generator, so empty dot. Okay. Oh wait, never mind. And instead of that, we just do self dot start, or self dot at start, self dot at end, and then it's just the actual samples. There we go. And then we just do np dot array of this. I think that's more efficient, probably. And it handles it just fine. D type is right, start is fine, end is fine. Got us our 11 points. Yeah. Okay, cool. To be fair, I think the at this method is probably not most amazing. I guess it would just be np dot is doing all this math out here the most efficient? I guess we have import time it. That's what this is for. If globals equals, or not globals, time globals np dot zeros, full some random number. Yep. np dot random random the default ing. Small detour, hopefully small, please. Time it's library. Okay. Time it. Actually, wait, no, I should just NT equals NP, I think, because it executes in its own separate little environment. Actually, I should just have it do that during setup. Setup import numpy as np. We also need to import numpy as np. There's more to time it though. There's time it has a whole, like, it has a full setup. Okay, fine. Floats, time's default. Setup is a string then that does this. But what does time it setup when called? Okay, so I do need to time it global equals like this. RNG. Actually, I'm gonna make a new one of these every time, so what else do we need to run? We do equals RNG dot what does RNG dot random look like? Equals v dot random size. Size is just the thing, right? Two thousand. Oh, that might actually burn my computer down. 200. Right, this scales exponentially, so 20 by 20 by 20 by 20. Cool. We start and then start T. Oh wait, no, this has to be a tuple like this. RNG.random looks like what? Type uniform? Uniform. Low is low equals -10, -100. High equals 100. Size equals oh, this is the you know. And I can use the this one. move 10, no equals 0, no equals 10, 5 equals 1, and 2 equals 20, starts at 10, and then t equals ng dot uniform low start. What? No. Size equals 1. That's t. Let's just calculate it like this, right? How did I miss? Oh, I missed both the start and the end. Okay. Yes. This is annual. NP calculus. NP dot. Mean, I think. Oh yeah, and then I need to clean this up. This is entity starts T. Entity minus start 2. NP dot mean, I think. Yeah, A. Zeros. And like 3 by 3. R2 equals empty dot 1's 3 by 3. Print R1 R2. Oh my god, R2. Right? Yeah, that's fine. wow. Okay, so then if I weight it to one side, do that mean start end this equals 0. Wait, W. Do you allow waiting? Or is it np dot something else? Average, yeah, average. Same idea. Let's see, it's from 0 to 5, and we're at 3. So you get well, if I don't know, this was like a 3 and a 7, then we should see 0. Yes, that's what I meant. Okay, so this is expected. And that means it should just work like that, right? Yes? Equals t minus start. I know, and t minus start t. Counting days. Time and statement is manual calc setup number no, like 100, and then globals equals np dot random dot default rng 20. What do we got? We called it rng. MT. Oh, ST. Average. And then the solution is just so to look 2 by 2 by 2 by 2. So have it. The axis is 0, which is which way? So this is also not fine, but average, but why? Because we have start and end. They should. So if we start end, end. Okay. So the first one is this, and then what is it that I need to stack them? Is it p dot v stack? Okay, so that axis 0. So that's 2 8s. Yeah, it's the same thing. So that is what this is. I don't even know. That's why I give you everything. I just did this. I just did it with average. Why is it not working now? Like this. And how many things are there? Okay, doesn't matter. I don't want to spend any time on this. This one, yeah, that's just true always. Okay. What? There. Start points is a that's why I gave you everything. You meant the world, yeah, okay. So that that's why. Actually, see, remember one. There's an ad break in 1 minute. As always, you can subscribe, skip the ads. Otherwise, obviously not an obligation. Otherwise, I will catch you up when everyone comes back, if anything interesting happens. Do we want to? Oh, it's fine. I'm just gonna put everything, all the way back. I'm gonna leave it the way it was before because then I can add stuff later if I want. Okay, there, that's fine. Okay, well. Control weights is more path nested scalar. Path scalar. Nope. Not a path scalar. There's a list. And what? How do we control weights? It is not just any nested though, it's specifically just a list of path scalars. So I have just a collection of path scalar. From maybe C equals 10 or none. Yes, this is an int. That's just the power, and then start T and end T are like this. So like that. Oh, wait. It's a collection of path and it's a scalar. Okay. And the time the T gets to be pushed onto here. Base. This is super. What? Or super dot init. Yeah. Super init like this, and how much are we expecting? We're expecting. There we go. That. I think so. I think that's fine. Int 8 will do even, so we're gonna shift it to this. Recast Let's start being. Actually, I just thought of something. Why do I do all of this? I mean, it anyways defaults to float 64, which is, I think, the best thing for it to default to anyways. So I really shouldn't be even, like, messing with that at all, except for here, when the precision does matter. We should default to the precision of the path for a path mask. That makes sense. But everything else not so much. Why would I do any of this? Just start PNG. start. Oh, all right. Scalar cast value. Source dot precision. Sorry about that. Okay, so we have this, that is, I think, the entire init method done. Yeah, hell yeah. We pass start TNT. We have all of our stuff up here. This is get return shape. On the other side, I'm gonna say goodbye. There you go. So I do need to fix this, but first we're gonna fix the render method. First thing we fix about the render method is the signature looks like that. And there is no get dx. No dx's. I forgot I need to do render with dx, which in this case is just a tile for a linear, but not for the B-spline. At dx. Let's render. P dot repeat. The array that I want to repeat is this one, and we need to do it samples times. Render dx. It's not render with dx. That should be good. All right. Now that that's done, we close this one, close that one, that one. Okay. So render. What do we need to? 1, you need to be marked as an override. 2, that looks fine. And I think I am just going to use this at because there's no nice trick for it. But p dot is zeros. And what is the thing? It is samples. And self dot return, get return shape. I equals this. IT and enumerate. Enumerate this one like this. Same idea as this add method, yeah, all the same. And start. Okay. Yes. Now this is all of the. Okay, what does get basis do? Oh, lovely. Is Eisen int. P is an int. T is a path scalar, and not is self precision. This is generator, right? I think. Don't. Never mind. It's not a generator. Okay. Why do I have lin space? Or else there's lin space appeared. Okay, fine. There we go. And again, close this. We're not working on that right now. We're working on. Oh. Do I remember what basis does? No. I better hope so. What is this? This is start T. Oh, right. Is shape, fill value, and then date type. Path, right. So that space between these two. Oh wait, yes, no, it is a path array, but it's not of the points. It's oh, okay. So we take. Oh, I know what this is. Okay, so this one, it's like it's a path. All right, that's fine. But when you do this, this returns. Yeah, this one just returns a path This one turns a float. Yeah. Okay. And I don't think I need to change any of this. Both these all return floats. Yeah, they all return floats. Cool. So, sorry about that. This, yes, so do all of that. I think it's just So control points can be. Oh. If control. Oh, control points. Control weights. What if it's none? Equals control weights if control weights is not known else. P dot ones without its I'm tired of the pain. So we set this, which kind of handles in case that our control weights, right? We said that it could be none if the user just wants to like give it the default weighting, which is 1. So we say, well, I mean, obviously, if the user provides a control weights, we use that. Otherwise, we just put a bunch of 1s there. And Well, I guess we just put this. Wait, let me do this. Plus, there we go. And equals. I know how this works. Like this. There we go. That's smaller. It works. That was one example of this in here, where we made something and then safe casted it. Yeah, okay. I don't know what I was thinking of. Right here, we're gonna do it all the way up in MP float 64 for the most accurate stuff, and then as type I should get more water. I should actually end the stream now. Forgot. I went over my time. Well, that is gonna be it for today then. Thank you all so much for watching. I really appreciate it. Stuff. Ending stuff. I do the socials kind of. I post my VODs on YouTube, and then I have a Discord. Discord, there's the announcements and schedule updates and stuff. You can chat with me on Discord, talk about coding, games, whatever the fuck, doesn't matter. And then I post my VODs on YouTube. This VOD should be up today, probably. I think I did the last VOD on time. I don't know. Yeah. Couple other things. We got next stream is probably next Sunday. I'm thinking about doing a shorter stream on Saturday late at night, even though I said that I wasn't gonna do that anymore. Maybe we do Friday. We'll see. I'll look at that. If I have the time, we might. But I definitely should be on. I should stream Sunday, same time. Was it 1:30, 2 p.m. PST to 6-ish. Couple of things, I think. No, that is it. I remember stuff. I'm a professional streamer. I stream professionally. Might as well. Okay, we're gonna raid Eve. She's really cool. She does art and Minecraft and sometimes other things. Yeah. Start the raids. Let me get the raids messages up. Raid. Top one is if you are not subbed. The bottom one is if you are. And yeah, again, I really appreciate you all watching. Remember, take care of yourself. Dying is bad for your health. I know, crazy. Drink water, eat food. Uh, Try not to overwork yourself. Sometimes it's hard, but as much as you can. You deserve it. And I will see y'all next time. Bye.